This is a continuation of the video on graphing radical functions. So this screen should already have been written down. If you have not seen the first part of graphing radical functions, please go back and watch that first. Let's review what a reflection looks like in an equation. This first question asks what y equals the square root of negative x will look like. To do that, we need to consider the parent function graph. So let's begin by just remembering what the parent function looks like. The square root function looks something like that, and 0, 0 is a point on it, and 1, 1 is a point on it, and 4, 2 is a point on it. Let's concentrate on that point, 4, 2, as a point on the parent function graph. Okay, well, if we're taking a negative value for x, I know at first you might think, wait, we can't have a negative under the square root. It's not defined. Well, that's true if I make x a positive number and plug it in here. Then I'll have a negative, let's say, 4 if I make x 4, and that's not going to work. But what happens instead of choosing a positive value for x? I choose a negative value for x. Let's say negative 4. If I choose that for x, then I get negative 4. And negative negative turns to a positive 4. I can do the square root of positive 4. It's 2. And so when I plug in negative 4, I get positive 2. And you may be able to see where this is going. If you choose negative 1, negative negative 1 is positive 1, and the square root of positive 1 is 1. And so our graph looks like that. And that's y equals the square root of negative x. And I hope that you can see that this is just a reflection over the y-axis. So if we look at this as a reflection over the y-axis, let's look at the ordered pairs and how they've changed. The parent function has the point 4, 2. The corresponding reflected graph has the point negative 4, 2. So what changed is the x coordinate. And that's important because when we look at this equation, we notice that this negative is happening to the x. It's saying do the opposite of x. And so that's a huge reminder for you to go and pick a point on your parent function and then change the sign of the x coordinate and plot that new point. And then you have an idea of where your new graph is going to go. So let's look at the difference here. How is that going to compare to y equals negative square root of x? Well, again, let's start with a graph. My parent function looks like that. And the point 4, 2 is definitely on it. Okay, we'll start by trying 4 again and seeing what happens. The square root of 4 is 2, but now it says apply a negative to that. So my answer, my y value, would be negative 2 in this case. Well, that, for negative 2, is down here. Let's try it with 1. If x is 1, square root of 1 is 1. But my answer is negative 1. So 1, negative 1 is around there. And so we end up with a function y equals negative square root x, which is the parent function reflected over the x-axis. So again, look at the ordered pairs for the points and ask yourself what changed. 4, 2 became 4, negative 2. The y-coordinate changed signs. And so you may remember that we spoke in class at length about if it's happening under the radical with the x, it's happening to the x. And if it's happening anywhere else in the problem, not under the radical, we automatically say it's happening to the y. And so because this is outside of the radical, we say it's happening to the y, which means that we're doing the opposite of the y coordinate. So you're not likely to remember, oh, if it looks like this, it reflects over the y-axis, and if it looks like this, it reflects over the x. But if you're always asking yourself the question, is it happening to the x or the y, you can pick a point and change it, the x or the y coordinate, and then you'll be able to see where your new graph should be, even if you have to do that to a couple of points to get there. So let's just generally review transformations. If something is happening to the x, for instance, y equals the square root of x minus 3, this is under the radical. It's happening to the x. And so that, in this case, is going to be a shift left or right. In this case, right 3, because it's the opposite. Left if it was a plus something. And so what you're doing is adding or subtracting to the x coordinate. Now think about this. If y equals the square root of x is our graph that's like that, and this says to shift it right 3, then your new graph will be over here. And so what's happening to the x coordinate? You're not subtracting. It says subtraction here, but really 0, 0 is now 3, 0. So we're actually adding, in this case, 3 to the x coordinate to get to our new point. I want you to think about what the graph looks like before you jump to whether using math you need to do addition or subtraction. Now a stretch or a shrink can happen to the x, as in this case, or it can happen to the y, as in this case. Notice that when it happens to the y, it's not with the y, it's just not under the radical, which we automatically say is happening to the y. If it's happening to the x, there's something a little tricky. Then you're going to multiply your x coordinate by the reciprocal of this number here. So in this case, that would be 1/2. Now that's a little tricky, so it might be easier in the case of a stretch or shrink that's happening under the radical to just plug in a random x, figure it out, and get the y and plot the point. But when it's happening to the y, you just multiply by this number to the y coordinate. And so that's pretty straightforward. I'll show you an example of both of these so that you can see how to apply that to a problem. We'll come back to that when we have a graph in front of us. The last reminder is that if it's not happening to the x under the radical, then it must be, happening to the y. And that's really important. You know, you hear me keep saying it over and over. I want to make sure that you remember so that you're always looking for whether something is happening to the x or the y. Okay, so this is number 10 from your square root worksheet. Make sure you're going to the right place. I'm sorry about whatever this is. It just copied it weird. When you're going to graph a square root or a cube root function, the first step is to graph the parent function. And so always start by doing that. You can do it with a dashed or dotted line. You can do it in a different color. Since this is square root in the problem, we will use the square root parent function. I know that that's 0, 0, 1, 1, and 4, 2. And that gives me enough of a start to graph that. The next step, and you'll follow these same steps either sheet that you're doing for square roots or cube roots. The next step is to write your transformation in words. So we'll need to go ahead and look at each piece. And I see this -3, but it's being added to the square root portion of this problem, which means that it's a shift down 3. It could just as easily have been written at the end here after the radical. So be careful about that. It's a common way of writing it so that there's no mistaking whether it belongs under the radical or not. This 2 is a stretch. The stretch, is it happening to the x or the y? It's happening to the y because it's not under the radical, and it's a stretch by 2. And so we're going to be able to multiply our y values by 2. The next step, after you finish writing your transformations, is to apply the stretch or the shrink to points from the parent function. So you're going to pick the specific points and you're going to apply that stretch or shrink. Remember what we said, if it's happening to the y, we're going to multiply the y value of that point by 2. And so we'll go ahead, and this doesn't change because the y coordinate here is 0. Multiplying doesn't change it. Here, the y coordinate is 1. If I multiply that by 2, I get 2. And so I go up, and this is where my new point will be. Let's use a different color. All right, and this point, the y coordinate is 2. And if I multiply that by my stretch of 2, I get 4. And so now, in line with this, I'm going up here to 4. So if I make a dashed curve here, just so you can see where this is, you can see that I have a stretch. This is sort of taller. But I'm not done, because step 4 is to apply any shifts. Any movements up, down, left, or right need to happen now. So I know that this moves down 3. I need to take each point on this intermediate graph that I drew, this green dashed one, and I need to move everything down 3. And so this is step 4. I'm taking this point and moving it 1, 2, 3, down 3 and putting it here. I'm taking this point and moving it down 1, 2, 3 and putting it here. And the last point I drew was this one, so it's important to draw them big enough to look back at them and find them. Move that down 3, 1, 2, 3. And now you don't have to draw those arrows. I'm just trying to show you where we're moving from and to. And now my final graph looks like that. And so the blue showing here is the graph of our equation, y equals -3 plus 2 square root x. These same steps apply whether you're doing the cubed root or the square root. Of course, your parent function will be different. It's important that you start with the appropriate points to draw that accurately so that when you move them, they're also accurate. In summary, to graph a radical function, decide whether you're looking at a square root or a cube root function. Graph the appropriate parent function with 2 or 3 exact points as guides. Write your transformation in words. Remember, for stretches and shrinks and reflections, you need to ask yourself whether it's happening to the x or the y. Then apply the transformations to the parent function points. Sketching the new curve is your last step.